Japan is not building robots because they look futuristic. It is building them because the country is running out of people. In only 5 years, Japan lost more than 3 million residents. More than 90% of its municipalities became smaller. Factories need technicians. Farms need hands. Delivery companies need drivers. Hospitals and care homes need people who may never arrive. So Japan is attempting something no major country has ever achieved at this scale, turning artificial intelligence into a physical workforce. The machines are already leaving their cages. They're learning to see, make decisions, carry goods, inspect buildings, harvest crops, and work beside human beings. If Japan succeeds, it could create the blueprint for every aging economy on Earth. If it fails, the nation that once defined the future may discover that even robots cannot outrun demography. For decades, Japan's population problem arrived quietly. A school closed in a rural town. A family shop had no one to inherit it. A factory manager postponed retirement because there was nobody ready to take his place. Then the numbers became impossible to ignore. Japan's preliminary 2025 census counted 123.05 million people, a decline of 3.097 million since 2020. Population fell in 1,558 of the country's 1,719 municipalities. This is not a distant prediction. It is already changing where people live, what businesses can produce, and which services remain possible. The crisis is not simply that Japan has fewer residents. It is the balance between generations. A growing share of the population is elderly, while the pool of working-age people is shrinking. Each worker must support more of the economy, more public services, and more care. Immigration, higher workforce participation, and changes to retirement can all help. But none can instantly create millions of skilled workers. Japan needs productivity to rise even as the workforce falls. That makes automation more than a corporate efficiency project. It becomes national survival strategy. Japan is not starting from zero. Long before humanoid robots became internet celebrities, Japanese engineers were building the machines that transformed global manufacturing. Companies such as Fanuc, Yaskawa, and Kawasaki Heavy Industries helped industrial robots master welding, painting, assembly, and material handling. These machines were fast, precise, and tireless. But they were not intelligent in the way people imagine intelligence today. Traditional industrial robots perform carefully programmed movements inside controlled spaces. Put the same object in the same position, and the robot can repeat the task thousands of times. Change the object, block its path, or move it to an unfamiliar room, and the machine may become useless. Even so, the scale is enormous. The International Federation of Robotics counted roughly 450,000 industrial robots operating in Japan in 2024, about 10% of the global stock. Japanese factories installed more than 44,000 new units that year. This should have made Japan unbeatable. Yet a strange reversal was taking place. China became the world's largest industrial robot market, installing more than half of all new robots worldwide in 2024. American companies captured much of the software, cloud, computing, and artificial intelligence boom. Japan remained a robotics superpower, but the center of gravity was shifting. The old formula, world-class hardware with fixed programming, was no longer enough. The new race is about physical AI, machines that can perceive the world, reason about what they see, and choose an action. Instead of programming every movement by hand, engineers can train systems in simulation, feed them video and sensor data, and allow them to learn patterns from many examples. A robot may identify an unfamiliar package, adjust its grip, navigate around a person, and continue working. This does not make the machine conscious. It makes it adaptable. That difference could unlock the places where traditional automation struggled. Warehouses filled with constantly changing products, construction sites that never look the same twice, farms where every plant is different, and care facilities built around unpredictable human needs. In July 2026, NVIDIA announced a broad physical AI push with Japanese industry. Fanuc, Fujitsu, Hitachi, Kawasaki, Kubota, NEC, SoftBank, Sony, and Yaskawa were among the companies joining or building with NVIDIA technologies. The project spanned factories, agriculture, healthcare, shipbuilding, transport, inspection, smart buildings, and construction safety. For NVIDIA, Japan offers something valuable: decades of real-world engineering and industrial data. For Japan, NVIDIA offers AI models, simulation, and computing platforms that can make its machines more intelligent. It is a marriage between Japanese hardware and American AI, and both sides know they are racing China. The popular image is a humanoid machine replacing an office worker. Japan's more immediate reality is less dramatic and more important. Robots are being asked to move boxes through warehouses, inspect manufactured parts, deliver goods, monitor infrastructure, and support workers performing dangerous or repetitive tasks. In agriculture, autonomous machines may help plant, spray, and harvest. On construction sites, computer vision can identify hazards before an accident happens. Care is the most sensitive frontier. Japan needs more people to assist an aging population, yet care work is physically demanding and emotionally complex. Machines may lift patients, carry supplies, monitor movement, or connect residents with remote staff. But feeding someone, understanding fear, or noticing a subtle change in behavior is not simply a mechanical task. The goal, at least in the near term, is not a robot nurse replacing every person. It is a machine removing enough physical burden that one human caregiver can safely help more people and spend more time doing the work that requires empathy. The same logic applies to factories. Automation does not always remove a complete job. It changes the bundle of tasks inside that job. A worker may stop lifting heavy parts and begin supervising several machines. The economic question is whether training and wages improve as fast as productivity. If Japan already builds world-class robots, why are so many businesses still desperate for workers? Because buying a robot is not the same as making it useful. A large automotive factory can redesign an entire production line around automation. A small food processor, machine shop, or family warehouse cannot. Its products change. Its rooms are crowded. Its data may exist on paper. It may have no robotics engineer and no budget for months of custom integration. Japan's Ministry of Economy, Trade and Industry created the Ring Project to help regions adopt robots and develop local expertise. The government has also begun supporting robotics foundation models and the collection of real manufacturing data for AI. These policies reveal the true bottleneck. The robot itself may be impressive, but deployment requires cameras, grippers, safety systems, software, clean data, maintenance, and people who understand the workflow. The machine is only one piece of a much larger system. Physical AI also carries risks that a chatbot does not. A wrong sentence is embarrassing. A wrong movement beside a worker can cause injury. Robots must operate reliably when sensors fail, lighting changes, networks disappear, or a child steps into the path. The closer machines move toward people, the higher the standard becomes. Robots cannot make Japan younger. They cannot reopen every abandoned town or replace the social bonds lost when a community disappears. Technology cannot solve a demographic problem by pretending human beings are interchangeable with machines. But robots may change what population decline means. If a smaller workforce can maintain factories, farms, logistics, hospitals, and infrastructure, then economic decline is not inevitable. Japan could preserve more capacity with fewer people. It could also export the systems to South Korea, Europe, China, and eventually the United States. countries moving along the same demographic path. This is why Japan's experiment matters far beyond Japan. For the last generation, the dominant technology companies placed intelligence inside screens. The next generation wants to place it inside machines. That transition will create new winners in chips, sensors, simulation, industrial software, and robotics. It will also determine which nations can continue producing when workers become scarce. Japan once taught the world how to build better cars, electronics, and factories. Now, it is trying to teach machines how to understand the physical world. The question is not whether robots are coming. They are already here. The question is whether they will arrive fast enough.